looking at relative minimum and maximum. And then in this episode, we're looking at how to calculate the critical points for multi-variables, for multiple variables. We're going to see how to classify those critical points. Then after that, we'll start taking our questions. The first partial derivative must be 0. First partial derivative, f subscript x is 0, f subscript y, certain points must be 0. And then a comma b are those points we are going to find, which is the critical points. So by the time we solve this, you get your point, a comma b. Then the second classifier, after getting the critical points, is to classify those critical points by using second order partial derivative, which involve this formula. So this is a formula we are going to use to classify the critical points. And that critical point is a comma b. We are going to find by solving this equation, f of x, f subscript x equal to f subscript y equal to 0. When d at that your point is positive, is greater than 0, and the second order partial derivative with respect to x at that your critical point is also greater than 0, that point is relative minimum. So that's the first classification. The second classification is your d at that point, at your critical point, is greater than 0, and this one is less 0. At that point, at a comma b, that point, a comma b, is relative maximum. The top point, if d less 0, negative, is less 0, that point, that critical point, which we have gotten from the first step, is called saddle point. And finally, if your d is equal to 0, then that point, a comma b, may be maximum or minimum, and other techniques will be what will be used to classify. We can even say at that point the test fail. Okay, the test fail if your d is what is equal to 0. If your d is 0, the implication is that that point, a comma b, may be minimum, maybe maximum, maybe saddle point. So we don't even know which one it is. So other techniques will be involved to classify. So that's that on these aspects. Without further ado, let's go straight to questions. We have the first question. Find and classify all the critical points f of x comma y equal to 4 plus x cubed plus y cubed minus 3xy. So the first thing we do when we want to find and classify critical points, the first thing we do is to get the partial derivative with respect to x, which will be equal to what? Don't forget, when you're doing partial derivative with respect to x, the other variables will be kept as constant. This is a constant, that's 0. This will be 3x squared. This is 0 with respect to x. Then here, we're going to take 3y constant and differentiate x, 3y. That's the partial derivative with respect to x. Can we also get partial derivative with respect to y? Go back to that function again, do that. So that will be, differentiate this one. This is a constant, this is a constant. That's 3y squared minus 3x. Then at critical points, f of x, f of y, f subscript x, and f subscript y must be equal to each other, and they must be equal to 0. This implies that f subscript x is equal to 0 and f subscript y is equal to 0 at critical points. At critical points, f subscript x and f subscript y must be equal to 0. Then we solve that and get that point, that critical point. The first one, we can solve that equal to 0. So that will be equal to 3y equal to 3x squared. So 3 cancel, we have y equal to what? X squared. So we have that. So don't forget, we have 2 equations. Then plug in this one into the second equation. This is the second equation we have, and that will be equal to, anywhere you see y, you put x squared there. Then we can factorize. So from here we have x equal to 0, or this one, x cubed minus 1 equal to 0, x equal to 1. So that's what we have now. then we need to get the corresponding y value. Okay, so we can go to any of the when x is equal to 0, come to this place, this equation, y equal to x squared. So when x is 0, y is also 0. We are going to have point 0, 0. What of when x is 1? When x is 1, do the same thing, plug into this equation. When x is 1, so we are going to have 1, 1. These are the critical points. So the critical points 0, 0 and 1, 1. So these critical points are the ones we are going to use to make our classification, because we want to know, is that point, is it minimum, is it maximum, is it a saddle point? So these are the questions we want to answer by using these critical points. Let's classify the critical points. Classify the critical points, we need to find the second order partial derivative, and that will involve using this formula: second order partial differential respect to x and second order partial differential respect to y, then minus f subscript xy, then you square that. These brackets are just the points we want to test for. Now we have 0, 0 and 1, 1. Okay, so the first one can have 0, 0 here, 0, 0 here, 0, 0 here. D at these points, at the critical points. So we'll find this one, second order differential respect to x. So if you do this one, that will give you 6x. Okay, then we also need to find this one. Do it again, respect to y, second order differential respect to y. Do this one again, respect to y, and that's what? That's 6y. We need f subscript xy. I mean, we are differentiating this first order respect to y, and that'll be what? That'll be minus 3. The next thing to do now is to test the points at 0, 0 and put it in this place. The second order respect to, this one at 0, 0, that will give you 0 times f subscript yy at, we have the value, this one at that point we are testing, that's also 0. Then minus this one, f subscript xy, we have the value, and don't forget we are going to square that, and that's what? That's giving us minus 9, which is what? Which is negative. It's less 0. So at that point now, this 0, 0 is saddle point. Let's get this d also at this critical point at 1, 1. We have this one at 1, 1 at 6. We have this one also at 1, 1. Check your second order partial differential respect to y is 6y, and y is 1. So that's what? That's 6. Okay, so let's begin to substitute. Then we also have this one as minus 3. So substitute, so we are going to have 6 times 6 minus minus 3 squared, and that will be equal to 36 minus 9. So we don't need the value, we just want to know, is it positive or negative? It's positive. So if it's positive, that is not enough. We need to check this one at that point. That's 6, which is also what? Positive. Okay, and when such happens, when your d is positive at that point, and this one at that point is also positive, then that point 1, 1 is a relative minimum. Hit the notification bell, click on like button, and begin to type your comments. Finally, share the links of this video on all your social media platforms. Thank you for doing that.